Okay, so this is page 5 of the packet, and we're going to go over how to write a rule for a function. So here, now many of you can look at this input-output table and you can say, well, I know what the rule is without doing anything. And most of you are probably going to say, I know 3 times 2 is 6, 5 times 2 is 10, 7 times 2 is 14, 9 times 2 is 18. So my rule is y equals 2x. And you would be correct. But I am going to show you a method that will work not just for the easy problems, but will work when the problems get harder too. Now, one thing I do want to mention is that the rule is always an equation. If you write the rule is 2x, I will mark it wrong because the rule has to be an equation. Y equals 2x. Okay, so now when I look at an input-output table and I want to come up with the rule, I look at my y values first and I say, is there a pattern in my y values? So to get from 6 to 10, I add 4. To get from 10 to 14, I add 4. To get from 14 to 18, I add 4. And here I add 4. So I notice that my change in y, which is written like this, it's called delta y. My change in y is 4. And I notice my change in x each time is 2. And when you put the change in y over the change in x, it's 4 over 2, you get an answer of 2. And that 2 is what I call the multiplier. We are going to write a rule that follows the slope-intercept form. Now, I've mentioned this form to you before. And when we solve for y, I've asked you to always try to put the x term first because we're trying to mimic that form. So this m, in this case, I didn't mean to erase that, is 2. So we can think of that as the multiplier. So you write y equals 2x. And in this case, your rule is done. But there are going to be times when you do the multiplier and then you have to add or subtract something. So we're going to go over a few like that too. So let's look at number 2. So number 2, I look at my change in y, that's plus 1, plus 1, plus 1, plus 1. My change in x is plus 1, plus 1, plus 1. So my change in y over my change in x is 1 over 1, which is 1. So my multiplier is 1. So I write y equals x. Now I could write 1x, but we know that's not necessary, so I'm not going to. But then when I look at my rule, I say, well, that doesn't work because if x is 1, it says the output is 0. So y equals 1. This is one of those examples where now I have to add or subtract. And to get it to turn from a 1 to a 0, I have to subtract. So once I write my rule of y equals x minus 1, I'm going to try to see if it works for all the others. So 2 minus 1 is 1, 3 minus 1 is 2, 4 minus 1 is 3, and 5 minus 1 is 4. So this rule works. Now notice in this next one, I'm not using x and y, they're giving me f and d. So if somebody supplies variables for you, you have to use the variables that they supply. So I'm still going to say, okay, what's my change in y? And it's plus 3. What's my change in x? And it's plus 1. So my multiplier, my change in y is 3. My change in x is 1. So I know my rule is going to start out with y equals 3x. And then I go to test it to see if I have to add or subtract anything. And in this case, it works perfectly. 3 times 1 is 3, 2 times 3 is 6. but I didn't use the variables that were supplied, so I am wrong. Okay, let me try to. So I know my multiplier is 3, but this time my output is F instead of being Y, and my input is D instead of being X, so my rule is F equals 3D. Now looking at number 4, to go from 2 to 2.5, I add a half. 2.5 to 3, I add a half. 3 to 3.5, I add a half, where my x's are increasing by 1. So my multiplier is the change in y over the change in x, which is 1/2. And I notice that alone works because half of 4 is 2, half of 5 is 2.5, half of 6 is 3. So I know that my rule would normally be y equals 1/2 x, but in this case, I can't say y equals 1/2 x because they gave me different variables and I have to use the variables I'm supplied. So my output m equals 1/2 my input n. And for number 5, it's the same numbers, so it's the same rule. They're just seeing if I can use the different variables. So c equals 1/2 b. Okay, so now we're going to turn to page, let's see, I think it is page 10, but I have to move. I have to move this whole thing. There we go. Okay, sorry, didn't want to go to page 10. I wanted to go to page 8. Okay, so on page 8, it says this, what they're having us do. They're having us write a rule, but this is a little different. They start with a graph and they ask us to write a rule. So to do this, I'm going to say, okay, here's my graph. I have to make a chart for the graph. So when x is 2, y is 0. When x is 4, y is 1. When x is 6, y is 2, 8, 3, 10, 4. And I'm looking for a pattern between my input and output values. And I'm going to write a rule that describes this relationship. So I notice my change in y, if you look, y is changing by 1 each time, but x is changing by 2. So my rule has to start with 1/2 times x. But half of 2 is 1, and that's not 0. So I know I have to do something else. So half of 2 is 1. To get to 0, I have to subtract 1. So now I'm going to see if that rule works. Half of 4 is 2, minus 1 is 1. Half of 6 is 3, minus 1 is 2. Half of 8 is 4, minus 1 is 3, and that rule works. Okay, so you see, as the pattern gets a little more complicated, my rule comes in handy. So now we're going to turn the page. So now you're on page 9, and I want everyone to look at checkpoint number 2. So checkpoint number 2, let's see if I can move this. Checkpoint number 2 says Write a rule for the function represented by the graph. Identify the domain and range of the function. So the first thing we do is we put the graph into a chart. So when x is 1, y is 0. When x is 2, y is 3. When x is 3, this is 6. And when it's 4, it's 9. So I notice my y is changing by 3 when my x is changing by 1. So my multiplier is 3x. So now I know I might have to add or subtract. So if I do 3 times 1, I get 3. What do I have to do to turn that 3 into a 0? Well, I have to subtract 3. So let's see if it works. 3 times 2 is 6. 6 minus 3 is 3. 3 times 3 is 9, minus 3 is 6, and 3 times 4 is 12, minus 3 is 9. So that works. Okay, so I want you to stop the video, and I want you to try to do number 3 on your own. Turn the video back on and see if you have it right. Okay, so the first thing I do is plot my point, or the points are plotted, I identify them. So when x is 2, y is 6. When x is 4, this is 7. When x is 6, this is 8. And when x is 8, this is 9. My y is changing by ones, plus 1, plus 1, plus 1. But my x's are changing by 2's. So that means my multiplier is 1/2. So I know my rule is going to start with y equals 1/2 x. Now I have to see what I have to add or subtract. So 1/2 2 is 1. What do I have to add to make it a 6? I have to add a 5. 1/2 of 4 is 2. Add 5 and you get 7. Half of 6 is 3. Add 5, you get 8. Half of 8 is 4. Add 5 and you get 9. So y equals 1/2 x plus 5 is my rule. Okay, so hopefully this video helps you find the rule of a function.